Alright, we are going to talk about third identity now. Third identity basically is a square minus b square is equals to a plus b, a minus b. You need to understand a few things. Number one, both terms, we are having two terms and both terms are perfect square. First value is a perfect square, second value is a perfect square, and you always have a negative sign between the terms. And when you're going to use the identity, that would be, there will be two brackets and you're going to have a plus b, a minus b. First value plus second value, first value negative second value. Before we start it, we need to understand a few more things. Number one, if we are dealing with perfect squares, it means you need to know about at least first 20 perfect square. Like 1 square will give you 1, 2 square will be 4, 3 square will be 9. So if I'm going to have 9 somewhere, I'm going to use 3 square there. And if I'm having 100, I'm going to use 10 square. If I'm having 2 to 5, I'm going to use 15 square. Sometimes examiner is not going to give you a question where you're having square term. You are going to convert it in a square term, just as the first example we are going to discuss, that is x square minus 4. Now x square can be written as x whole square and 4 is a perfect square, so I can write it 2 whole square. So see the third identity, that is a square minus b square, that is a plus b, a minus b. So x square minus 2 square can be written as x plus 2, x minus 2. Before this, when we were doing first identity and second identity, we were writing down x plus 2, x plus 2, x minus 2, x minus 2 because we were dealing with first and second identity. But in the third identity, we are going to open it. We're going to write it x plus 2 and x minus 2. Let's do more examples. X square minus 16 can be written as x square will be x whole square. 16 is a perfect square. You can see 16 is a perfect square. 16 is 4 square. So I'm going to take this value. I'm going to write 4 square for 16. And then I'm going to use the identity, that is x plus 4, x minus 4. Let's do it quickly. K square minus 81. K square can be written as k whole square and 81 is 9 square. So k plus 9 and k minus 9 is the final answer. This is factorization using third identity. 25a square minus 64. Now 25a square, there are two terms, but both are a perfect square. 25 can be written as 5 and a. So 5a whole square, if you're going to expand it, you're going to have 5 square, that is 25, and a square, that would be a square, that will give you 25a square. 64 is 8 square. So you're having 5a plus 8, 5a minus 8. Now, 36x square minus 49. 36x square can be written as 6x whole square. 49 can be written as 7. So this would be 6x plus 7, 6x minus 7. Students get very confused if the examiner is going to use a constant term first and the variable term afterwards. But this is just like that. You're having two terms. Whatever term is coming first doesn't make any difference. 81 can be written as 9 square and 16x can be written as 4x whole square. So that is 9 plus 4x, 9 minus 4x. 64 minus 9 a square is another example, and that would be 64 can be written as 8. 9a square can be written as 3a whole square. That will give you 8 plus 3a and 8 minus 3a. Now, if I'm going to do minus 4h square plus 81. Now, this is confusing because before that we have studied that a square minus b square means you're going to have a positive term first and the second term will be having negative sign before it. So, I can swap the values. I can write positive 81 first and minus 4h square afterwards. Doesn't make any difference. So, 81 can be written as 9 and this can be written as 2h. So, this will be 9 plus 2h and 9 minus 2h. Now, here we are having a question, 2x square minus 18, which is not a perfect square. X square is a perfect square, but 2 is not a perfect square. 18 is not a perfect square. So what can I do? I can take 2 common and I'll be having x square minus 9. Now this is x and this is 3 square and 2 will be with the bracket till the end. So this will become x plus 3 and x minus 3. Similar example, 3x square minus 147. I have taken 3 common, so I'm left with x square minus 49. So that would be x whole square minus 7 square. That will give me x plus 7 and x minus 7. Now, if I'm having 36 b square minus a square, I can write it 6b whole square and a whole square. So that will give me 6b plus a, 6b minus a. 49c square can be written as, yes, 7c whole square. 9d square can be written as 3d whole square. 7c plus 3d, 7c minus 3d is my final answer. 3x square minus 27y square. Again, it's not a perfect square. What I'm going to do, I'm going to take 3 common. And don't forget to write 3 with the brackets till the end. So I'm left with x square minus 9 square inside the bracket. This will be x whole square minus 3y whole square. That will give me x plus 3y and x minus 3y. That is my final answer. Alright, again 2x square minus 50y square. What can I see? That it is not a perfect square. But if I'm going to take 2 common, let me write it down with all the brackets, and I'll be left with x square minus 25y square inside the bracket, and both are perfect square. This is x whole square, this is 5y whole square. So x plus 5y and x minus 5y is my answer. So what are we doing? We are actually taking something common so that we are having perfect squares inside the bracket. Now again, we are having a question which we have done earlier, but we are going to have variables with it. So 64a square can be written as 8a whole square, and this can be written as 2b whole square. So 8a plus 2b and 8a minus 2b is my final answer. K square minus 1 by 4 8 square. What I'm getting now? I'm getting k whole square, but the second term is a bit confusing. 8 square can be written as h, but 1 by 4 can be written as 1 by 2h. Remember, 1 by 2. If you're going to take square of 1 by 2, what will happen? 1 by 2 whole square will give you 1 ka square over 2 square. That will give you 1 over 4. So I can write 1 over 2 for 1 over 4, because 1 over 2 whole square is going to give me 1 by 4. So my final answer will be k plus 1 by 2h and k minus 1 by 2h. Now, similar examples. D square minus 16 over 25. This is simple. This is D, but 16 over 25. Now, think about 16. What is the square root of 16? That is 4. What is the square root of 25? That is 5. So, I can write 4 over 5. And I'm going to have 4 over 5. Taking the square means 4 square will give me 16 and 5 square will give me 25. So, I'm having D plus 4 by 5 and D minus 4 by 5. Similar example. I'm having 4 by 9. So think about under root of 4. What are you going to get? 2. Under root of 9, that will give you 3. So 4 over 9 can be written as 2 by 3 whole square. And x square over 25 can be written as x over 5 whole square. So that would be 2 by 3 plus x over 5 and 2 by 3 minus x by 5. Last example. If I'm going to see this example, 90 is not a perfect square and 10 is also not a perfect square. But if I'm going to take 10 common, what will happen? This will become 9 x square y square, and this will become 1 because I have taken 10 common. So first of all, I'm going to write 10 till the end, and now I'm going to think about a perfect square. 1 is a perfect square. I can write it 1 whole square. 9x square y square can be written as 3 for 9, x for x square and y for y square. So 3xy whole square will give me 9x square y square. So this is 3xy plus 1 and 3xy minus 1. That's it.